Hello and welcome back to the channel. Hope everybody's had a wonderful holiday season. This week I wanted to do something a little festive, a little different. I wanted to walk through something that helps people hopefully understand stuff that I've been working with for a couple of years now. Sometimes I want to start something new, something from scratch, something that can be like a prototype, a creative idea that I can see through in one sitting or in a weekend. Now, from most people's perspective, things like video games, websites, software, it sounds really complicated and really hard. And worse than that, a lot of people assume you'd have to pay some kind of money or go through weeks and weeks and weeks of learning just to try something out. This video is meant to sort of bring back some of the old types of content I did over 10 years ago, where I walk through a project from start to finish, and hopefully people can learn a ton about video game development, web development, or just programming in general if you've never thought about it or done anything like that before. Today's idea is a small, festive video game that hopefully is slightly randomized, that people could pick up and play, kind of like one of those Chrome internet disconnected games or one of those mobile games that you can play just to buy a couple minutes here and there. To make this game, I'm going to use just one file, and it's going to be primarily in JavaScript. Now, JavaScript is a web development language that's been around for a long time. There's frameworks and libraries people have made on top of that, and those are essentially ways that people have modernized that language, ways people have made it a little bit more specialized towards what they want to accomplish. We're just going to use simple, no bells and whistles JavaScript, and I'm going to try to explain every step of the way, but I'm sure if this is an interesting video for a lot of people, I can do follow-ups and break down certain components, maybe even add on to this video game or make this into a sort of series. So let's get started right now by making a brand new file. Now, the text editor I'm using right here is known as Visual Studio Code. It's free to download. It has a lot of support from people if you're Googling problems. That's one of the main things I look for when I'm trying out a new technology or a new app is there a lot of people online who have answered questions before that could help to, get me out of situations if there's a problem or if I'm just trying to get started with something and I don't want those roadblocks. Again, similar to the motivation behind why I'm making this video, and hopefully it'll help a lot of people out along the way to sort of shortcut those weeks or months of boilerplate stuff that is not super fun. Let's get right into the fun stuff. So if you're working with me, once you have your text editor open, let's create a new file, and we can call this anything that we want. I'm just going to call it game.html. HTML is the extension, you call it, for a file that can be opened in any web browser. It's essentially a basic web page, and that's all we're going to need. Now that we're ready to go, we have this file set up, we have to add a couple instructions, and this is to tell the web browser, hey, this is the language I'm working with, these are the parameters for how I'm going to get started. It's actually really simple. With the basic template structure of HTML, all you need to do to say, hey, this is a web page, is type in the letters HTML. A lot of text editors, as you can see, not only allow you to color code it, but also add what's known as the end tag. This is essentially a container, a circle, and inside of that, we're going to throw in all of our wonderful, wonderful code. So hopefully you're still sticking with me here. Let's go in and let's create the body of the web page. This is essentially the content that doesn't include metadata, titles, things that the web browser is going to use for tracking. We don't need any of that. We're jumping right into the body. And we actually don't need anything else except for our script. And our script starts just like that. And this is how you express that I'm about to write something in JavaScript, the language I discussed earlier. If you want to learn more about JavaScript, it's a very, very commonly used language. In fact, as I said before, most frameworks and libraries use this down under the surface in order to do any fancy stuff on the internet. We're actually going to use it in order to make a full-fledged video game. And I've done this in the past. I've actually published a video game using JavaScript with a couple extra additions on top of it. And you can bundle it up, so to say, so that people can download it from Steam. So don't just think this is only for websites. You could also create a fully contained application, and a lot of people do, not only for the desktop, but even now for the iPhone, for Android, for all sorts of different devices. JavaScript's a very good and versatile language to get started with if you just want to cut out the middleman and do something that's widely compatible. So now, in order to get started, step one, I want to create a canvas, so to speak. I want to create something that allows me to render, draw, add content in the middle. Now, instead of just starting off with common HTML elements. Some of these are known as paragraphs or divs, divs, which are sort of a generic representation of web elements. I'm going to do something that allows it to be more compatible with different machines and is actually in a vector format. It's known as SVG. Now, this vector format means that no matter where you're looking at this, how big or small your monitor is, everything's going to show in the same quality. It's going to be essentially lossless or infinitely scalable. We can make it small, we can make it big, and it's never going to have pixelated, crunchy edges. But before I get to that, I want to make sure we can actually resize the web browser that anything I add is going to fit. So what am I thinking here for resolution that I kind of want to constrain things to? It's kind of like if you think about movies and aspect ratio, it's good to actually determine this before you get started so that if a user opens up a really skinny browser like on an iPhone or a really beefy one like on a 4K display, what I'm recording on right now, everything can shrink or expand to fit everything properly. So I'm just going to target the very common 1080p resolution. This means that we have 1920 pixels width and we have a height of 1080. Now, luckily for us, the pixels are not going to matter because, again, we're working with vector graphics. Everything should shrink and expand, always look good. But I want to target this sort of rectangular format just so that I know what's inbounds and out of bounds for my video game. You can use something else if you want. Let's do step 1. Create a container. Just like how you saw up there, I use this abbreviation that stands for constant. This means I'm creating a variable, something that's not really meant to change going forward and represents a bit of data I'm going to use later on. So let's create a new bit of data called container. We can actually create something in the web page just with 2 lines of code. All we need to do is ask the document or web page to create some type of element for us. The type of element I think will be div. This is the generic sort of catch-all container. Now, once I've created it, I need to add it to the body. This is, again, why we have a body in the first place. Document.body.append is how we add things to the end of it. We can also add things to the beginning, the middle, but it's empty right now. So we can just do .append. Everything should work out very well. Now, after we've added it, we need to stylize it. We need to tell it, hey, this is what you should look like. This is how you should operate. A style is normally represented in a different language known as CSS, but we don't have to get into the details of that today. All we need to do is write, using JavaScript, certain very simple shorthands that allow us to constrain this element, to make it fit exactly what we want it to fit. So what we do is we type in container.style. Now, again, if you're using something like Visual Studio Code, you'll see a lot of autocomplete results, things that it suggests for you to do. And this is a great way to get started and just to see what are the basic capabilities. It might not be as detailed, it might not have all the explanations you need, but at least you'll be able to make sure you're doing things right and you'll get those red squiggly lines, as you can see right now, if you haven't finished a line of code or if something is not spelled correctly or if something doesn't quite exist in the way that you thought it did. So we want to create this element as a fixed element, an element that is meant to stick with you no matter where you scroll, no matter how big the browser is. There are a couple different options for position, but fixed is, again, something that's meant to be elevated, that is sort of non-negotiable. If you've gone to websites and you've seen those do you want cookies banners at the bottom, or things that don't really move no matter where you go on the web page, that's normally fixed. There are a couple other ways to make that happen. There's always multiple ways to make just about anything happen with web development, but fixed is something that, kind of like how it sounds, is fixed in place. It's not relative, it's not absolute. These are other terms that you might learn as you do CSS. It's something that is stuck there. Now, after we do that, what we want to do is simulate what happens when you're full screening a video game. We want every single part of this container to be locked and loaded on all of the axes, all top, left, right, and bottom. And I actually say that because that is what it's called in CSS when you want something to be locked into each of those respective sides. So real quickly, let's do this. Style.left equals 0. And to make this a little bit more straightforward, we'll just copy and paste and make this left, right, top, and bottom. Now, believe it or not, this is already a functional web page. This would already run in a web browser if we opened it up. To prove that, let's set the background color to something really simple like orange. And now let's open it up. It shouldn't matter what web browser you're using, but for reference, I'm using Firefox. So you can see right here our beautiful website rendered in HD. Again, just double clicking will open this up. And if you wanted to, you can right click and hit inspect, and you can see that code, that wonderful final result and how it turned out. Now, if I resize the web browser, make it bigger or smaller, you'll see it's always on the top, left, right, and bottom. Very simple nomenclature, very simple way to make this happen. But we're just getting started. That's step one. Now, right before we get to step two, I want to remind you to like and subscribe below if you haven't already. Also, check out the links in the description for this wonderful Christmassy wallpaper by the Basic Apple Guy, wonderful graphic designer who makes these types of things all the time. There'll also be links in the description for the GitHub page where you can look at the complete code that I'll use in this video. It'd be great if you wait before you go there though and don't spoil yourself to the end, but I totally wouldn't blame you if you wanted to. You can also submit comments there and make changes, as well as do what's known as forking, where you copy and clone that repository onto your own account if you have one, and you can make some adjustments from there. And then if you want to, you could even make a request to merge those changes in with mine. So lots of fun stuff to be done, but let's jump right back into it. Step 2 out of 10. Now let's create something that actually resizes, right? We created an element that's always going to be constrained to each of the edges of the web browser. But if we actually shrink the page, we want to keep that 1080p experience preserved no matter where or how you're looking at this. So how do we do that? It's actually a lot more simple than it sounds. So step 2, create a place to draw things that resizes to 1080p. Let's create another generic element. This time we'll call it canvas. Now to get started with, we want this canvas element to have the exact 1080p width and height we defined up above, or if you changed that, whatever you preferred up above. Now that's the width and height we're using. If we highlight it, you'll see it matches up with this right here. Now, in order to get it to resize, we're going to have to add something a little bit fancy. But before we get there, again, so it's easy for us to see how things are moving and grooving as we go along, let's add some window dressing, some fun, maybe festive inspired styles that'll help us to differentiate later on where this canvas is. So let's make our border color equal to literally green. Let's add a border style that is dotted, so it looks, like it sounds, kind of fun. And let's make the border exactly, I don't know, 5 pixels wide. Any raw number we type in with nothing after it will be interpreted as pixels by the web browser. So that already will work, but we need to add it now to the container instead of the document itself. Another good reason to add these containers is that we can now reference them and move them around as sort of a group, a combined unit. So once we save and we refresh, you'll see now a border right around the web page. But there's a problem here. If we resize, you'll see it doesn't match up completely with what we're looking at. So in order to make it scale, let's literally add a scale. So we do canvas.style.scale. Now, how do we determine what that's going to be? How do we know how much to shrink or expand the web browser? It's actually kind of simple. We can grab the height or width of the window itself, and we can divide it by the width of our 1080p expectation. This will create a number that allows us to say, oh, it should be twice as big or half as big as the expectation. Now there is one gotcha, which is that we don't know if the width or the height will be the limiting factor. What's going to be smaller? For example, if the user has 1080 height, will be perfect. But if they shrink that height and it's maybe half as big, we want the scale to be 0.5. That's exactly what this will do. But if it's the other way around, if maybe their width is the problem, we want to be able to scale by whichever number is smaller. Luckily, there's already a way built into JavaScript to pick two numbers, whichever one is smaller. It's called math.min. It'll pick the minimum out of any list of values. So let's paste in, and we'll also now want the width. And I'm noticing now that I made a small typo here where we want that to be height in height and this to be width in width. This is what the final result should look like, where you have width divided by width, height divided by height. Now there's one small gotcha. Since I added a 5 pixel wide border, I need to account for that here. Since we don't just want that 1080p surface to be visible, we want that border on each side to also be visible. So how about instead of using a number like 5, let's create another variable called border width. And let's make that variable border width equal to 5. Now we can copy and paste that down here below. Width plus border width multiplied by 2, again because we want there to be a border on each side. Now that we've added that to the width and the height, I'm going to save, and that'll apply some formatting here to the code to make it look a little bit more readable. Now keep in mind, any of these enters and white spaces in JavaScript are ignored, so you can add them wherever you want to your code base to make things look a little bit better and ideally be good for humans. That's an important note with code, is that later on, humans are the one who are going to read it, edit it, and improve it. So don't just make things optimal for the computer all the time. Now, before we refresh the page and take a look at what we have, let's add one more thing. When you scale something using this technique, you need to define where the origin is. We need to tell the web browser, should it start in the center, the top right corner, the top left corner? Where's our reference point for doing that shrinking and expanding? Right now, we want the top left to be our reference point. So let's do canvas.style.transform origin top left. And if we save and refresh our page, we now have this beautiful, beautiful 1080p dotted green surface. There's only one problem. It'll fit any size that you open up, but if I then resize the web page, it's not going to match anymore. And that's going to be a problem going forward. So let's get to step 3. How do we listen for that resize and make our canvas change accordingly? So step 3. Let's listen for resizing. This is going to be a little bit more complicated, and now we're going to get into the real heart of how this is going to work. Some of the more advanced techniques that we're going to use later on as well to listen for things like key presses when a user moves a character around. But even though it's a little bit more complicated, you might be shocked on just how simple it stays. All we have to do to start to listen for when the window gets resized is type in window.onResize. There are several different methods, they're called, or blocks of code that execute when things happen on a web browser. Again, like resizing or pressing a key or clicking a button. This is a super simple way, every time the user resizes a window, to run a block of code that we determine. And a simple way to define a method or function, these are synonyms in the programming world. All we need to do in JavaScript, at least, is type in 2 parentheses. These represent the things going into that function or method. Right now, that doesn't matter to us. We don't have anything that we need to accept, so to speak, from this method. Then we type in =arrow, and this allows us to define a method in the fewest letters and symbols possible. Super straightforward. Then we type in a curly bracket to start and end that block of code. Congratulations, you've just learned how to write a method, a function, a small logical unit in JavaScript. Now, believe it or not, all we have to do is highlight this wonderful code here we wrote earlier and paste it into the method so that it runs whenever the window gets resized. Now I'll save it so that we get that pretty formatting I like so much, and let's run it. Let's save and refresh the page and see what happens. Every time we resize the window, you'll notice that the width and the height is intelligently chosen, and we'll always see that beautiful box of 1080p always aligned to the top left. And wow, to me it feels like we've already made a lot of progress, but we're only getting started. Let's head on to step 4. Step 4 is where we create an SVG. Like I mentioned before, an SVG is an image format that can be scaled, changed, and is very cross-compatible on different web browsers, so we don't have to worry about old things like Internet Explorer, Chrome. Everybody should treat them pretty much the same. So let's go down and type in step 4, create an SVG. So what do we do to make that? SVGs have a little bit more when it comes to the setup steps, but not too much. We actually have to say what specification, what set of rules is the SVG using. Instead of just creating an element like we did before, we're going to use this new method, createElementNS, which stands for namespace, or the set of rules we'll be following. And you'll see this suggestion, so we can just copy and paste that right out of there, and now say we want to create an SVG with that URL as the specification. And if we click on that and take a look at the exact set of rules, and this is something kind of cool with web formats, where a lot of times things are publicly accessible instead of, deeply encoded or compressed or compiled into ones and zeros. But we're not done yet when it comes to telling the web browser what set of rules we're following. We need these rules as well. Once we're done with that, let's move forward. You can click on those links to learn more about them, but we want to get right to the nitty-gritty. Next up, we're going to do something similar to adding styles. We can use both styles, which again are CSS, ways that the web browser interprets directions for what color things should be, how things should be aligned like we were doing before, but also attributes on the SVG level, in a way an internal representation of the way the SVG should operate. And SVGs, again, are a graphics format that can be used in a wide variety of applications, not just websites. So we're going to do two different sets of instructions. First, let's start off with what we already know about, the styles. Let's set the background color of this element so that when we're done with this step, we can see exactly what we've done. Let's use a festive color, in this case thistle, which is a actually accepted HTML color in all modern web browsers. Now that we're done with that, let's set up some instructions. These instructions for SVGs are known as attributes, so we can do svg.setAttribute and we're good to go. First, let's set up the conception of a view box. This is the playing area, so to speak, that the SVG will use. Unlike 1080p, why don't we pick a square area so it'll be easier for us to do some more dynamic effects and it matches sort of a retro look. So let's do set attribute view box and let's make this equal to, I don't know, 1080, since that's the smaller number out of 1080p. But this isn't good enough, right? We want to use variables for everything. So let's make this equal to play size. Now, to move that variable inside of this string, this set of numbers and letters that are expressed with a quotation mark, we can just replace that beginning and ending quotation mark with these backticks, something that you get with the tilde key into shift if you haven't used them before. And now, something similar to the methods, we use curly brackets. But not just that, we need to add a $sign to the beginning so that JavaScript understands exactly what we're putting in there. Now that we've put play size in there for the viewing perspective, the sort of drawing area for the SVG, let's actually set the width and the height on an attribute level so the web browser knows exactly what those values are as well from the outside, not just the inside. So let's do set attribute width and height for the play size. And with that, we're already almost done. We just need to do a little bit more. Of course, you might be noticing we haven't added it to our canvas yet, so let's add it to our canvas. And I'm noticing now that I've used append child and append interchangeably. These are actually things that are somewhat identical from a programming level. It again demonstrates that with web development and programming in general, there's normally tons and tons of different ways to make the same thing happen. Append, as you can see from the suggestion, accepts a list of items, whereas append child normally expects just one item. Okay, right before we save and move on, I'm noticing one small thing we have to change. Instead of using the HTML rules like I did up here, we need to change this to be the SVG rules. Otherwise, there's going to be a mismatch. Now let's save, refresh, and we see our beautiful thistle-colored box. And that's it for step number 4. Thanks for sticking with us. Let's move into step 5 and get halfway done this ambitious video game project. For step number 5, let's create the player character, the thing that we'll be able to move around as. And all we really need for that is a simple shape. Let's start off with a circle. So let's go down to step 5, create a player circle. To do that, we can use SVG terminology and hopefully leverage a lot of the stuff that we've already learned up to this point. To get started with, let's make a variable that represents how big we want the circle to be. I think 50 pixels is a pretty good size so that there's a lot of space to work with. Then let's create a new element. Circle equals document.create element, and we still need to use that namespace. And of course, we want to use the exact same URL up above instead of getting caught in that trap of using HTML instead of SVG. And we'll call this circle. Next, let's set up how big this circle should be. If you're familiar with circle terminology, this is known as the radius. So let's set the attribute. The shorthand for this is just the letter R, and let's make this equal to the circle size. Next, let's set up where that circle should show up. So let's set up the X and Y coordinates. The shorthand for this is actually CX and CY, and I think it might be good to set this up right in the center of our playing area. So let's make this play size divided by 2 for CX and CY. And we're already almost done, but again, let's set up a friendly color so that we can differentiate this. And instead of doing styles, we can do the SVG terminology for fill, or the filling color to make inside. And let's make another festive color, maybe dark sea green. And again, you can Google a list of HTML color names. There's a lot of really fun ones out there if you want to change this up and make a different festive palette of your own. So now let's add this to our SVG by doing svg.append circle. and let's save and refresh, and now we have our beautiful circle. Let's do a couple more quality of life tweaks before we get out of this section. Mostly, I'd want to center this SVG. In order to do that, all we need to do is tamper with CSS just a little bit more. Let's type in canvas.style and set the display mode to be flex. This allows us to add alignment rules. Then let's do canvas.style align items center and canvas.style.justify content center. All of this means that anything we add to the canvas should be aligned to the center both horizontally and vertically. So now let's save and wait, gotta add a T there, refresh, and boom, now we're centered. And this thing will persist no matter how big or small we make the web page. Great, we're officially halfway through the steps and on to step number 6. Step 6 is when we start to dive into some of the dynamic video game stuff. Instead of the setup, making things look nice, we're going to start moving things around in our video game. To get started, we'll do something very similar to what we did before when we detected resizing on the window level. Step 6, similar to resize, let's handle the keyboard. We can start off in just the same way, window.on key down. This is going to listen for any time the user types a key. But this time, we actually do care what comes in. We want to detect exactly what key the user is pressing. In order to do that, we can actually type in any letters here to represent a variable that is the event. That's what happens when you use on key down, you get a keyboard event. We could call this E, but let's call this event for shorthand, so it's easy to tell what exactly we're working with. And then we're making a function just like we did above with that arrow in the curly brackets. Just to test if this thing is working properly, let's actually pop up a message every time the user types a letter. We'll remove this later, but just for testing purposes to make sure everything's going the way we want it to, let's type in alert, which pops open an alert using the default web browser terminology, and then let's type in event.key. And let's refresh the page and let's start pressing on letters. And you'll see every time you press on a letter or even the arrow keys, you get a pop-up that says exactly what you've typed in. And you can even do shift, control, meta, which is the command key. You can do any of these things in order to get that alert. Now that we know that this works and what exactly that key is, it'll be a letter like A or a special term like arrow up, we can create logic around that. And the way that I would want to do this is by using what's known as a switch statement. In my opinion, this is a particularly easy to read bit of code. It also is pretty optimized if you're writing native code. So all you need to do is type in switch and then the thing we are switching on or that we're going to be applying logic to. So e.key. Now, in order to have pathways, we type in case and then what we're trying to make a case for. So here, whenever the user types in A, the next code after this colon will execute. Pretty straightforward, yeah? We can type in alert A, and then in order to specify that this case and the whole switch statement is over, we break out of that segment. And now, right before we check on our progress, I have to make this say event instead of E, save. And now let's check it out. If I press A, I get a pop-up that says A, but if I type in other letters, it shows up in this default Firefox find in page interface. Now, if we want to disable that, we can actually take care of that real fast before we move on to the later functionality. We can just type in event prevent default. And this will make sure that any default web browser mechanics don't kick in. So we refresh the page and now A happens and we don't get that Firefox find in page interface. So now let's move on to the functionality and make this actually do something. So how do we do that? Well, I think to make things simple, let's make another block of code called move. And inside move, we're going to move any element in the direction that we pressed. Right now, we only have one element, the circle, but it'll be useful going forward to make it so that this function can accept any element. So let's type in element here, just like how we typed in event down below. Now let's call move. And since A is traditionally left, let's make this go left. Now we can also handle arrow left here by simply typing in arrow left in the same exact case group. So now move left will be called whenever the user types in A or the left arrow key. Now, what does move actually do? Right above here, we defined x and y, the coordinates for the element or circle. To move to the left, all we need to do is detect what that position is and then adjust it accordingly. So let's create a variable called x and make that equal to the element get attribute cx. You might think this is good enough, but elements usually encode all of their attributes as strings, which are not things we can add numbers to. Now there are several ways to convert this string back into a number again. We can do parse int if it's a whole number, we can do parse float if it's a floating point number, or we can add a plus sign, which performs a simple arithmetic on it before we do any further calculations. That's all we have to do, a plus sign, and then get attribute. So now that we have the x coordinate of the element, all we need to do to get the new x is do x minus 1 to move it to the left. And once we have that new x value, we can do element set attribute to make it update on the web page. Now a couple more tweaks to get this to work. First, we didn't give the element we're moving yet down here on key down. We need to pass that in. And up here, we need to accept the direction. So now these two things match up. We can save, refresh, and you'll see that the element does move very slightly to the left. That seems like a little bit too small of an adjustment to even be noticeable. So let's create a new variable called, I don't know, delta, that determines how much each press of a button should move the element. And let's make that equal to 10 pixels. Now we can replace 1 with delta, refresh the page, and you'll see the element moves much farther. Good. Now we have to handle all of the other directions. Let's start in the move function. We can make another switch statement, this time on direction. Now left can adjust our new x value, and we can move this set attribute up into that statement and then break out once that's done with. We can now also create something for right, for up, and down. And we'll fill these in once we handle the key presses first. So now let's go down here and copy our original block, paste and save to format it, and replace A with D and arrow right. This will be our handler for when the user presses right. Now let's also create that same exact thing for up. That would be W or arrow up. And we'll create one final one for down. Arrow down. Let's go up here and actually add the functionality. So now we can paste in here, and let's rename these to be a little bit more specific. So we can do left x and right x. And we need to add instead of subtract the delta. And then for up, we can do up y, again subtracting instead of adding in this case. And down will be back to adding again. And now the final touch is to make these x's into y's and use the same exact technique up here to interpret the cy that we get from receiving the element. Now let's save, refresh, and we can move up, we can move right, we can move down, and we can move left. Very close to done, but there's a couple more quality of life things I think would be good to add. First, to support moving just about anything around on the screen, we should stop passing in the direction directly and instead have it also be part of the element itself, just like cx and cy. We can actually encode any attributes we want, and it won't affect the way that SVGs are interpreted as long as it's something that we invented and isn't already in use by the system. Instead of having move left, right, up, and down, let's go here and type in circle set attribute and create a new attribute called facing. And in facing, we'll pass in that direction. Then we can take the move function, move it down here, and only pass in circle. Let's update that for everywhere. So here we have right, here we have up, here we have down. Now, again, this is super useful because if we add elements later on, they can constantly be updated based on the direction they're facing. This could even lay the groundwork if we wanted for a snake-style game where every second or so, your player object would move in the direction it's facing, and the arrow keys simply adjust that direction instead of moving it directly and doing nothing else. So it sets up the stage for future video game concepts, but also, more importantly, makes it so that we can use this in a more versatile and modular way, which is really the essence behind making functions like this through a lot of programming. So now let's go back up and update that move function. All we need to do is replace that first line of code and get direction as element get attribute facing. And we can set up a default direction that the circle should be facing right before we call anything. So set attribute facing, and let's just have it be facing to the right. Now if we save and go back to the web page, we'll see that we have the same exact functionality, but now it's written in a little bit of a better way. There's still one problem. What happens if we reach the very edge of the square? If I hold down on the right key, you'll see eventually the circle disappears. It'd be a lot better if it wrapped around to the other side of the square. Now how do we make that happen? All we need to do is add a check here right before we set the actual attribute of the element. What we want to do for left and up is make sure that if the value gets essentially less than 0, we loop back around to the bottom or the max value. And similarly, when we're going right or down, we want to make sure that we go from the biggest value possible to the smallest one. We want to make sure we know how big the player is or any other element we eventually pass into move. Otherwise, it'll snap to the top, bottom, left, or right when the center of the circle is passing. It makes more sense to snap when you're on the edge of the circle or element instead of in the center. The same way that we detect the X and Y, let's detect the size of the element by getting the R value. Now that we have the size over here, let's detect if the final destination minus the size is equal to or greater than 0. Then we'll do the original destination. Otherwise, we want to do the right-hand side of the playing area. This would be play size minus the size of the element. Now let's save, refresh, and see what we got. So now if we move to the left, we can sneak our way over, and right when we get there, boom, we now cleanly adjust to the right-hand side. Okay, so let's do that for the remaining areas. For the right-hand section, we'll do right x plus, instead of minus size, is less than or equal to the play size, right? Instead of seeing if it goes under 0, we want to see if it's over the max value. If it isn't, then we're good to go. Let's do the original right x value. If not, we want the other side of things. Instead of it being the max value, again, we want the smallest value. This would be the size of the circle itself. Let's save, refresh, and see what we've got. So now we'll move to the right. Moving, and right as we get to that right-hand side, boom, we cleanly move, and we can now alternate between the left and the right-hand sides. Now we'll do a very similar thing for up and down, except we'll just do y values instead. So starting off with the up, we'll do if up y minus size is greater than or equal to 0, then we're good. Let's do the original up y. Otherwise, we want that maximum value, and the maximum value is play size minus size. We can save that, and before we even refresh, let's move on to this one, because it's much the same thing. Plus size less than or equal to play size, then we're good to go with down y. Otherwise, we want it to be the minimum value. So instead of play size minus size, again, we want the minimum value, the size of the element itself, instead of the maximum value since we're going down. So we'll save, we'll refresh, and now we can try up and down. They should both now work exactly the way left and right did. We go down, boom, up, boom. Everything's snapping, moving around very cleanly. And that's a wrap for part 6. Now we have this element cleanly moving left, right, up, and down with the arrow keys. And better than that, it wraps around so that you can be flexibly moving around however big that play size is, as long as it's a square. Now let's move into part 7. For part 7, we want to do something I sort of foreshadowed before. We want to move the player constantly in the direction it's facing. Similar to games like Snake, we want things to be always in flux, so the user might have a better or harder time achieving the goal that we set up at the end of the game. So in order to do this, we can create a tick system. If you're familiar with other video games like Minecraft, for example, there's always a tick that's happening either every second or 60 times a second, and this is when world updates can happen. So if water's flowing, it'll flow based on the tick rate of the engine. This is also kind of an interesting thing because we can make things faster or slower. You can determine that tick rate yourself, and it can happen, 1/10 of a second every second, and that's when updates will happen for the game logic. In order to set up something that constantly updates every 1/10 of a second, we can use something built into JavaScript. Really easy, in fact. We just call something called setInterval, and now we can create any kind of function we want inside using, again, that same pattern we used before. Right now, all we actually need to do is type in move circle, and this will make our circle move function call, just like it did up here, in the direction it's facing because we encoded it as an attribute. Now we just have to set up how often it runs. Now, this is actually given in milliseconds, which is a pretty cool way that JavaScript does things. I suppose that's because it expects there to be a lot of quick and fluid updates in the web development language itself. We'll type in 100 now to do 100 milliseconds or 1/10 of a second. Now we can save and run, and we'll see that immediately our circle starts moving. Better than that, it'll still use our existing logic, so you'll see it wraps around, and if we change to go up or down, we can now change the direction it constantly moves. And if we sort of spam the right button, we can get a built-in speed up effect in case the user's trying to rapidly get out of the way or into the way of something on the playing field. That's it for step 7. So what's next? We already have a resizable canvas, this playing field that looks and operates nice no matter where you're looking at it. We have a player object that moves not only based on when the user presses on the arrow keys of the keyboard, but actually operates based on where it's facing, much like games like Snake. Well, we have to actually add an objective to the game. I think a really good place to start would be to add a bunch of smaller, similar circles that are moving all over the place on the playing field that the user's going to have to interact with in order to win. So, continuing on, step 8, randomly generate, how about we make it snow that the user has to pick up. First, let's figure out how much snow we want to create. I think a good way to do this would be to create levels, but we need to determine what level the user's playing on. So instead of creating a constant, something that's not meant to change, let's create a let variable, something that is designed to change over time. And we'll make the level that we start at level 1. Then let's determine how much snow we want. The snow amount should be equal to the level times, how about 10? So we have 10 pieces of snow on level 1, 20 on level 2, and so on and so forth. And we don't necessarily need a maximum amount of levels. We can just throw in as much snow as the user can handle towards the end. Now let's determine how big each piece or circle of snow should be. I think 10 is good. And now let's create another container so that we can hold all the snow. We'll call it snow group. And this means that later on we'll be able to detect just how much snow remains on the playing field without having to do some more complicated logic. Now let's copy and paste that namespace from up above so that we don't lose track of that SVG URL like we did in the beginning of the video. Boom. And now we'll type in G. That's a group in SVG terminology. Now let's add that directly to the SVG so we don't forget. And now let's create a for loop. This is a bit of code you'd find in just about any programming language that runs a certain amount of times. So similar to a method that only runs once, or in this case we had a method run every 1/10 of a millisecond, this will run how many times we want. So in this case we'll run it based on the level and we'll create that many snow pieces. So how do we do that? Well, a really good way, a simple way that happens in most languages is by creating an I, or an index variable, that'll go from 0 to the given number. So we'll do while I is less than snow amount, I plus plus. So now this bit of code is going to run 10 times for level 1, 20 times for level 2, and so on. So now let's create a piece of snow inside of here. Snow equals document, create element, namespace, and we'll actually copy in this, but we'll create it as a circle, just like we did above. Now let's set up snow to actually look like snow, right? So let's set the attribute to literally the color snow. Now we want to put that snow on a random location anywhere in the playing field. Luckily, there's a built-in way to generate a random number between 0 and 1. So if we do math.random, that'll generate a random number between 0 and 1. It'll be obviously with many decimal places most of the time. If we multiply that by the playing size, now that random number will be between 0 and that playing size. So using that, let's do snow set attribute cx and add the ending parentheses and do the same exact thing for cy. Now that'll be randomly generated on any location within the boundaries of the playing field. We're almost done already. Let's set the radius to the snow size, and let's set a facing direction. Why don't we make it face down, since that's normally the way snow falls. Even though it'll wrap around if it uses that built-in move function, it'll still be nice to have it facing down to sort of reinforce that festive nature. Now let's add it into the snow group, and again, that snow group is already actually in the SVG, so we don't need to do any more steps than that. But I think it'd be kind of cool to immediately, right here in the for loop, to set up our random movement. And instead of moving at a steady rate, let's make this a random tick rate. But to prevent it from going too fast, let's start off at 50, which is half of the speed that we move, and now let's randomize that second 50, right? So instead of it just being 100, it's a random number between 0 and 50, with a minimum of 50. So it'll be 50, 75, 80, some number in that range. Now let's just add in move snow, save, and check it out. Now we have a beautiful interface full of snow falling, exactly 10 pieces because we're only on level 1, and we have our guy moving at a steady rate. But you can see these snowballs or snowflakes, whatever we want to call them, are moving at slightly different rates. Time for step 9. For step 9, let's show a HUD so the user knows exactly how far along they are and what the sort of objective of the game is. We'll also sneak up to step 8 to maybe detect what level we're in and then display that as well in the user interface. Okay, so let's go down, type in step 9, add a HUD. Okay, so let's keep track of how many things are caught. That's our main goal. and then go down to add a caught label. And this will be, again, something that we add inside of the SVG. So we'll do create element ns, and we'll want to add in our SVG tag, and we'll want to make this text. Then we'll go in and copy that and add in the attribute where we want it to show up. Now, instead of cx, we can do x for the x coordinate. Let's just add it at an arbitrary place, let's say 50 pixels down, so it's not, really right on the edge. Similarly, for y, let's add it to 100. And now let's set the color. So I think a good color for this would be, how about a festive moccasin shade? And we'll set the text inside to say something fun. So maybe we'll add a snowflake and we'll say snow caught. Now, in order to actually display something, we might need to replace these quotes with backticks like we did above for the SVG view box. We'll do caught count. And now we'll want to show that it's out of the snow amount, the variable we already declared above when we were making this for loop. Now, right before we add it to the SVG, let's set the font. I think a good font for this would just be the default sans serif font in 30 pixels, and then we can add this to the SVG. Now let's save, refresh, and take a look. You'll see the text actually doesn't show right away, and this is because of an error. We used setFill, and that doesn't actually exist on text elements in SVGs, even though it does for circle elements. Now, I left this in here so that it'd be helpful to tell how to debug issues when you're working on a game like this in the web browser. Another good reason why web browser development can be really helpful, especially when getting started in programming or prototyping video games. So what do we do now? Well, we can just use CSS styles like we did before. Style.fill equals moccasin. If we save and refresh now, boom, we'll see that snow caught appears and that error no longer happens. So we can get rid of this debug interface. We have this beautiful label that says snow caught. We can even highlight it. And again, just like with everything else, it intelligently resizes because our code from the very beginning of the video. Now it's time to add a label for what level you're on. So to speed it up, let's just copy and paste all our code here for the caught label, and let's make this a level label. Let's replace these variable names here so we don't get confused later. And let's set up the Y to be a little bit higher up. And let's set the font to maybe be bold instead of normal. And then let's set this to say level and the actual level we're on. Now let's save, refresh, and you can see level 1, snow caught 0 out of 10. Almost already done with step 9. The only thing we need to do now is sneak up there and actually detect what level we're in, and then maybe add a way to change and update the level so that this game doesn't have to end after you just catch those first 10 pieces of snow. So right up here with level, let's actually do something tricky. There's a way for us to add things to the end of a URL. If you look up at the URL of this video, there's actually a question mark in v equals, and that's the identifier of the video. And it's how YouTube can serve you content based on some property or some attribute, you could say, that we pass in. Let's do that exact same thing here. Instead of calling it v, which is a little ambiguous, let's literally call it level. And let's add that to the end of the URL and detect it when it is there. So we'll create a variable called saved level. We'll make that equal to what is at the end of our current URL. So that's actually called the search string. Now, to make this a little easier for us, we can use a built-in technique that JavaScript has. Instead of just using location.search, we can grab the exact parameter using this wrapper called URL search params. We can paste that in and then do get level. This will look for any question mark level equals, and it'll remove the question mark, it'll remove the word level, it'll remove the equal sign, and it'll just give us that final value. Of course, we'll have to do one familiar technique, which is check if the level exists or not. We don't want to just throw anything in there in case the user went to this web page for the first time. So we use an if statement and we check to see if it exists. Then we want to make level equal to the number representation of that. So we do that same shorthand with the plus sign to convert a string into a number. Now, if the user has level 2, level 3, level 4, we'll be able to immediately tell and update the label, and it'll already update the snow amount. Now let's get to step 10, where we'll actually pass in a value for that level when the user is able to beat the first level. Okay, we're finally here. The last step of the video. Step 10, check if you caught snow. So how do we do that? Well, there's actually an interesting technique in JavaScript where you can have a method get called every time the web browser's ready to render something, or sort of the refresh rate of your monitor. All we need to do is type in window, request animation frame, and then we pass in a function. So we can use that same pattern, that nomenclature that we've used before. But how do we check for something here? And how do we make sure it keeps doing it every single time the window refreshes? Well, it's time to introduce recursiveness. Recursiveness, or a recursive function, is when a function can call itself. It's actually really straightforward. It's like those nesting dolls where there's always something inside. We can do this in JavaScript with two simple techniques. First, let's create a method like we did before, and we'll call it collision check. We actually can make it completely empty. Then let's pass that into request animation frame. But that will only call it once when the window's ready to refresh. What we really want to do, since it's a let instead of a constant, we can literally redefine it right below where we created it and copy and paste that request animation frame right inside of itself. This feels kind of nuts, but it works really elegantly. As long as we go down here and call collision check one time, then it'll run, wait till the window is ready to refresh, and call itself again. Run, wait again, run, wait again, run. And it'll do that forever until the user leaves the web page. Now it's time to actually check for collisions. So what we can do is loop through every piece of snow. We can do this by going to our snow group that we made before and going through all of the children. Once there's no children left, the user has won the level. Now let's get the position for each piece of snow. We can do this the same way that we've done in the past, where we can do snow.getAttribute cx, and then we throw in that shorthand plus sign, and then we go down here, we do the same for cy, and then we go down here for the size, and we do r. So now we have x, y, and size. We're good to go. Now we just have to detect when the player actually intersects with this piece. In order to do that, we can do something maybe a little too familiar to people out there who've taken a trigonometry class and detect the hypotenuse, or the line that connects the two circles. And if that line is less than or equal to the size of the circles, we know that they're intersecting, right? The hypotenuse is the line between the two center points. As long as that is less than or equal to the size, we're good to go. So let's create an intersect function, circle intersect. And we want to pass in two sets of coordinates. We can call that circle 1 and circle 2. And let's do that pattern here for making a function. And let's return the hypotenuse using math.hypotenuse. And let's say circle 1, each of these is going to have that x value, that y value, and that size value. So we'll do circle 1.x minus circle 2.x, circle 1.y minus circle 2.y. And we want to make sure that's less than or equal to the size of these two circles. Boom. That's all we need to do. However, we actually need to call this now. So in order to call that, we'll make a variable called doesIntersect, so it's really clear what we're doing. We need to pass in circle 1 and circle 2. In order to pass in circle 1 and circle 2, we need to create something that has these variables x, y, and size. Now, JavaScript has a really simple way to do this. It's called JSON, or JavaScript Object Notation. You can create an object, or let's say a group of variables, by simply typing in constant like we do normally, and then we can do circle 1 equals curly brackets and put in x, y, in size. Boom, that's all we need to do. Now, circle 2 should be the same thing, but using our user's position. So we can do circle, since that's what we called our user position, get attribute cx in the shorthand to turn that into a number, and do that for each of these things. Boom, boom. Once we've done it for each of these things, we now pass in circle 1 and circle 2 into our circle intersect function. Now, if there is an intersection, we know that that piece of snow has been caught. When the snow piece is caught, we remove it from the group. We now need to adjust the label. So let's go up here and copy this line, since we'll do the same exact thing. But we want caught count to now go up by 1. So we can do this in two different ways. We can either do caught count equals caught count plus 1, or if we want to get particularly fancy, we can do the shorthand plus plus, which makes it equal to that plus 1. But let's just keep it at caught count plus 1, since that's a little bit easier to read and understand, especially since this is meant to be a pretty easy beginner project. So let's go in, save, and refresh and see how it works. So now we're moving around, and as we catch snow, the number goes up, and you can see that the snow itself disappears. And this will keep going on until eventually we've caught every single piece of snow. So let's actually add a windscreen now for when you do catch all the snow and let you go to the next level. This will be the final part of the video, so thanks for sticking along with me this far. Okay, so where do we add our windscreen? I'd say the best place to do it is up here in our collision check. We can just check if there's no elements remaining, and if so, we can stop calling it recursively because there's nothing else to check for. Let's go up here and check to see if the caught count is equal to the snow amount. Now, as we discussed before, an if statement checks to see if the thing inside is true. Here, we're checking to see if count is equal to snow amount. Weirdly enough, though, in JavaScript, you can compare two different things, like 1 in the string 1, and this might actually turn out to be true. Link in the description to a pretty fun video called What about this concept. In order to prevent that weird kind of edge case, I always like to use 3 equal signs, which makes sure that if you're comparing a string or a number, it's the same type on both sides. You don't necessarily need to do that, but might be a useful thing to know going forward, especially if you're making more complicated logic in your own version of this game. Now, let's add some text to the screen. To make it easy to get started, let's copy and paste our level label from above so we don't need to do everything from scratch. Let's replace all these values so we don't forget to do it later. And instead of adding it to 50 on the x-axis, let's add it directly into the middle of our playing area. We'll change this color to maybe be a gentle slate gray, and we'll change our text content to say something fun. Why not you win? Then we'll change the font, maybe make that 100 pixels instead of 30 pixels. And we want to make this completely centered on the display. So similar to transform anchor, we have an SVG property, text anchor, and we can make this show up in the middle. So that's looking good for the win. But now let's show some stats so they know what they won instead of just saying you win, like an old NES game or something like that. Let's add this maybe 50 pixels below, and let's say down here, level complete in, I don't know, a certain amount of seconds. Let's actually detect how many seconds there are. In order to do that, we can actually start up right here with a start time and create a variable right here that represents our current date as a number. This is actually a funny gotcha. This is how many, I think, milliseconds or nanoseconds there are from the 1970s. So that's a little fun tidbit about JavaScript. And down here, we can detect, I don't know, I guess we'll call it current time. And we can do difference in milliseconds by doing start time minus current time. And then if we want to do difference in seconds, we just want to divide that by 1,000. But I guess there is one small thing. This could have a ton of decimal places, so we might want to round that number using math.round. So that really quickly is how we can detect just how long each level took the user to play. And that's all we really need for this bit. And let's add a couple more labels, I guess. We want to actually show them how they can proceed to the next level. In order to do that, let's just call that start next level. And let's paste in all of these new variable names. Let's add this maybe 100 pixels down from the middle, and let's call this, or let's add the text click anywhere to start next level. Let's make it a little bit smaller than that text since it's less important. And let's add, I guess, one more label so that they know that they can just refresh the page to start the current level over again, or they can click on like the back button to just go to the previous level. Since it's all part of the URL, like I was saying before, this should be, since it's just like YouTube where it's part of the URL, when you refresh or go back, it just uses your web browser's built-in functionality. Let's show this one like way at the bottom of the screen though, since we don't necessarily want the user to be refreshing or doing that. That's just like a good thing for them to know. Refresh or go back to try again, and let's make this a lot smaller, and we can make it normal instead of bold again. And yeah, that's all we need to do to actually display this stuff to the user. Now let's return so that this method ends. Returns how you, let's say, return a value from a method or just exit out if there is no value that needs to be returned. But we're not done yet. We actually need to add an on-click event handler, just like how we've added several event handlers before. And we want to calculate the next level. So the next level would just be the current level plus 1. Now let's do next level URL and use that fancy technique from before to actually add a value without having to do any of the hard work ourselves. Okay, that's looking good. So we can just make window.location.search equal to this value's string representation. This converts this fancy wrapper, as I said before, into a string. So yeah, we're good to go. Now that should automatically redirect them when they click to the next level. Let's see if it works. Go back here, refresh, we're on level 1. Now as we move around, we got to catch 10 pieces of snow. That's 2, 3, 4, 5. We can sort of mash the button again to try to sneak some more in. Ooh, we can loop around. We can even try to catch it on the way down by looping and maybe doing a little diagonal snake move. And then boom, you win. We can see that we're almost good to go. Just a couple more tweaks and we'll be done for good. It looks like our label in the middle is a little bit too large. So in order to fix that up, if we wanted to, we could actually right click and do some fancy work here, right? Remember, at any time you can edit things using this debug panel. It's really, really useful. I think it'd be nice to change this bold thing to be normal, maybe, and change that to maybe be 40 pixels. That looks good. So now let's bring that over here. We want to change that label right here to be 40 pixels and normal. And now we're good to go. We don't even need to refresh the page. We can just click to go to the next level. And now it says level 2, snow caught 0 out of 20. So we're pretty much good to go. But if we want to, we can hit the back button and we're right back here and it shows this text. Oh, I'm now seeing that this is a negative number. We should probably switch that to be current time minus start time. Since it's milliseconds from the 1970s, that would always show as negative. So now let's refresh to replay that level and try to get a better score as well. That second value was obviously accurate, but just negative. Now let's try to do a little trick here, loop around, and bam, grabbed it. So now we have level 1 complete in 17 seconds. Click anywhere to start next level, refresh or go back to try again. We can go to level 2. And that's it. So I hope you enjoyed this video. I hope you enjoyed this festive experiment. I thought it'd be kind of cool just to share a little bit of knowledge on how to prototype video games and use JavaScript. There's so much here that we went through, like SVGs, how to style things and change the color of things using either SVG properties or CSS properties, runtime loops and tick loops, how to do things recursively, what for loops, if statements, and switch statements are. I mean, 10 steps, but really this is how you sort of learn the beginning of JavaScript at the same time of learning how to build a video game. If you liked this video and you want to see more like it, make sure to let me know. I'm thinking about doing this kind of thing more often, even though normally I'd prefer to cover things that are applicable to everyone, not just people that want to do programming. This is still something that I enjoy sharing and knowledge that I think is useful for anybody to have. So thanks for joining me today. I hope everyone had a great holiday and I'll see you next week.